Salut everyone! In this video, I'm going to talk about the Nvidia current state on Linux. Are you ready? Let's get into it. As always, let's start with a little bit of context. This video won't be an AMD versus Nvidia type of video. This is not what I want to cover at all. If you have an Nvidia card right now, or if you plan to buy an Nvidia card, just watch this video because it's going to be really important for you to understand what type of real challenge you're going to go through and what type of limitation, but also what type of value added using an Nvidia card in a Linux environment is going to give you. If you are a big AMD fanboy, if you have an AMD GPU card, and you will never buy an Nvidia a video card, which I get, maybe you want to watch this video because you're going to see that it might not that bad to run an Nvidia card nowadays on Linux. And I would say on top of that, you're going to see all the cons related to Nvidia. So it might give you more arguments when you go into those big fanboy conversation on Discord, and you are like, yeah, AMD is better, I'm gonna prove it. You're gonna know all the weakness of the Nvidia user. Yeah, I know you will like that, AMD boys and girls. Now we cover the full context of this video. Let's get deeper into it. I think the first thing you need to understand when you think about the graphic stack within Linux, it's its complexity and why overall understanding every little part, at least at a high level, will give you a better perception of what is happening under the hood. So what you are looking at right now is called the graphic stack. And you can see that on the bottom, you will have all the hardware part and the Linux kernel here in the middle, which is going to make the link between the actual graphic driver, the compositor, and then the final client on the other end. In this video, I won't be covering the whole process within all those different levels of the GPU stack. But what I will cover is try to give you a better idea of where Nvidia and I would say NVK kind of lands for you to have a high level vision of what's going on. So we're going to start with how it works, for example, for AMD. So for AMD, most of the free driver, actually all the driver, they're going to be in this stack, right? Like the Mesa stack. So it's this one here. And you're going to find everything related to AMD free. For NVIDIA, in this case, you will find NVK in this stack. So this is the free open source NVIDIA driver Vulkan that is still in development and I've been covering for almost a year now on my channel. And what I want to say about it, because people get confused sometimes between those driver and the blob, which is now also open source. Those driver, they are getting better by the day, but they are still not ready. I would get further there, but you can use them, but they are not ready at 100%. What I would like to say is the evolution of those drivers is literally mind-blowing compared to what was my expectation at the beginning. My expectations were pretty low, but I have to say the dev, they did a great job. And to give you an idea, I think they improve the performance of the driver between my 6 months, I would say testing, because I tested the first time they released and 6 months after. And the uplift was crazy. It was 50%. And sometimes, depending on the game, it will be almost 100%. So in 6 months, they were able to get that far. So I'm going to put a link in the description below about the videos themselves, that you're going to have a better idea of where we are at. But the TLDR, sorry for the accent there, is that the NVK driver, they are already packed in the Mesa stack, and they work, but they are not working very well versus the proprietary one. On the long run, they're going to be equivalent or maybe better, but right now they are still in development. If you look at the right side here, you will have the proprietary driver. Those ones, they will include the AMG Pro version of the driver, because I'm pretty sure like most of the users know it, but you have two different stacks of driver with AMG on Linux. You have the free and the Pro, and obviously the Pro are going to be in this stack here. And you're going to have also the Nvidia driver as we know it for a long time. So as we speak, the latest driver are the 560. Okay, like it's one of the misconceptions here all the time. It's not because you are running, I don't know, let's say Ubuntu, and the latest one on Ubuntu has a 545 or the 550 that they are actually the latest one. To check which one are the actually latest one, you need to go on the website of Nvidia and check. You will have the beta version, which obviously are the one where they push like the new feature related to Linux. And you will have also the Vulkan driver, which are like specific to the new feature related to Vulkan. So just to double check, because sometimes you get lost in the number, the actual production branch is the 550. The new feature branch is the 560. And the latest beta version, so this one is a little bit behind because they moved this version to the feature branch version, is the 560.31. Long story short, you want to go, if you are a gamer, with the feature branch version, and I will explain you why after. Starting from now, you have a good vision of what is open source and what is closed source. So when it comes to GPU firmware, what really happened, because a lot of like websites talked about the actual situation that Nvidia is going to open their driver, but it's not really the case. What they did is they opened the GPU firmware, at least a part of it, to be able to be loaded within the kernel. So when you look at the GPU firmware, so I'm going to make a little line there, you will have the open source one, which will be the one pushed by Nvidia for all the newer cards, including Turing. So it's starting the 2000 series RTX. It will be updated and will be directly pushed within the kernel. So and you will have, so I'm going to continue, like you will have the closed one, which was the one previously, like I would say, like the main one, previously pushed by Nvidia. And this one is compatible with almost everything. Like at least the Pascal one are included in it. So the non-RTX. Okay, so this is the series 10,000XX without the, so yeah, 10,000XX. Because the 1600 is part of the Turing here. I know it's confusing, but don't be worried. So what it really means for us. For us, NVIDIA user, whether they are using the open source or the closed source, you won't have any difference. Like there is no difference. No difference. Because we are at a point right now where all the features, they won't get affected whether you load the open source or the closed source GPU firmware. So to be extra clear for the user, this is the actual like situation. However, if you are a maintainer, but you certainly know that already, but just for the end user to understand, the maintainer, he will simplify their life, okay, because now introducing an actual open source GPU firmware within the distribution, within like whatever they, you know, like they distribute, is going to be way easier because it's open source. Everybody on the maintainer side will have, I would say, like a better quality of life. But for the end user, it does not change anything. So now let's move to the next point. The next point is related to how the performance of your game is going to be affected by the complexity of this graphical stack. So depending if you are running a native game or a game through Proton within Linux, And depending if you are using X11 or Wayland, you're going to see that the path, while going through all those different layers, is going to be more or less complex. So let's start with the first one, the native game. So the native game, it doesn't go through any translation layer, whether you are in X11 or Wayland. And what it will do, it will go, so I'm going to simplify it, okay? But just to be like, like super clear like that, you're going to have a better understanding when we go to the performance. And I might make mistakes there. And I really count on you guys, like dev out there who have already maybe better understanding of the graphic stacks that I do, to give a comment in the description below. But the idea is like it's going to go through the driver, so NVK, or the Nvidia one, so we're going to call it Nvidia, okay? And then it's going to go directly through the 3D engine, and you won't have a lot of like different steps in the middle. And then it's going to render whether you are using X11 or Wayland. Okay, so this is really a simplified approach there, but it's just to give you like an idea for everybody else to get where I'm going there. Now, if you go with a Proton game, and you will see like here, it's a little bit different. So here it's a little bit complicated. You're gonna have obviously the driver stacks there, but then you're gonna have to go through, Wine, Proton. And then, for example, if you are using X11, it's gonna get out here. But if you are using Wayland, you're gonna have to go to a special layer called X Wayland, because right now Proton doesn't support like fully yet Wayland. So it's gonna have to go through this translator there, okay? And then go to Wayland. And to add complexity of that, depending on the nature of the game, so let's say it's a DirectX 11, 10, or 9, or it's a DirectX 12, the different like stack within the Wine Proton are gonna be different. So you're gonna have, if I remember correctly, like DXVK here, and here you're gonna have VKG3G. I always a mistake with this one, but you have DXVK and VKG3G. So you understand that those two layers, they're gonna add complexity to the overall process. So now you have a different perspective on what is the actual path of the different, like stream to get your video game working on your PC running Linux. What does it mean for the end user? Like if you have a card, so I'm gonna take my example, and like that, you're gonna have a really great idea of what will be the performance win or loss, depending on the type of game and depending on the type of like compositor you are using right now with Nvidia. So I'm gonna talking about my case. So me, I run RTX 4090 and CPU is 5950X AMD. And the last one, important, I'm playing in 1440p. And you will see there is still a difference, and I'm going to show you exactly what is it. Let's do the first game. I'm gonna give you 3 examples, okay? The first game is gonna be a native game. So the one which uses the less layer possible. And I'm gonna talk about Valheim, for example. What I noticed with most of those games is like on Windows, in terms of FPS, I would get 100 FPS. But I get way more than that, but it's just to simplify everything. If I run the game natively on Linux, I will get at least, I would say 15% more. Okay, so I would get plus 15% to, I would say, some game like Tomb Raider, I would get a solid 30% increase in terms of performance. And this is independent from the display protocol. So whether you are on Wayland or X11, you will have a better performance on Linux with the games that run native. Don't ask me why. There is certainly good reason right now, but that's my experience. It will be always equal or better. In my situation, with my hardware, it's always better. Now let's talk about the DirectX 11 game or 10, etc. Right? And what it means is like the game which will run through DXVK, as I explained earlier. So on Windows, let's say I have 100 FPS. Again, here you have two different layers in Linux. You have the X11 part and the Wayland part. In X11, you will get 85 to 95 FPS for the same game. So you will see you will lose between 15% to 5% in terms of performance lost. However, if you play on Wayland, you will see that your FPS are going to be a little bit lower. Not by much, but I would say you will be around like 80 to 90. And so it will be like minus 20% to minus 10%. So to give you a real like approach of what type of performance you can expect on Linux with an Nvidia card, this is where you would be. Now the one which kind of hurts the most is DirectX 12, which is going to be VKG3G. Hope I did it well this time. So a game, Black Myth Wukong, for example. All the newer games now, they are running DirectX 12, unfortunately, for the Nvidia user on Linux. And here it's going to be a little bit colder in terms of performance. There is a lot of posts out there which are already explaining them. I made a video explaining the situation. But let's say you have 100 FPS there. If you are on Linux, that's going to be a rough patch. So we're going to do X11 and Wayland. But I would say here you're going to be between 70 to 90 FPS. So you're going to lose like 30%. And sometimes you're going to lose like 10%, right? You know, it's like a fork. But on Wayland, you can lose way more than that. I had case where I was literally like losing 40, 50%. But I would say average, you're going to be, losing like a solid 40% to a solid 20%, at least. This is one of the big drawbacks you're going to encounter running Nvidia on Linux. It's related to DirectX 12 there. And you need to be aware of the situation if you want to switch. Now let's move to the next point. Like in terms of hardware, I have to say like all the RTX cards, they are supported pretty well. If you have a RTX card, you plan to buy a RTX card, you should be fine. If you have I think it's Pascal card, it's going to be supported only, as I explained earlier, with the closed source driver. So it's going to make your life a little bit more complicated on paper, but not that complicated to install. It's not that hard. But the big issue will be related to DirectX 12 and the implementation of Vulkan. Those cards, I owned a 1050 Ti and a 1080 Ti. On DirectX 11, the performance is great. Like it's going to be smooth. When you switch to DirectX 12 or pure Vulkan or whatever, like those one, they are struggling. Like you won't have the same type of performance you will get on Windows. Okay, like this is bad. I see too many time users which are like, oh yeah, I'm using a Pascal series card and I don't know, like it doesn't work properly, like it's struggling or whatever. It's because of your card. And the way it's built related to Linux is complicated. I'm not defending Nvidia, but I would say like the Nvidia Pascal cards, they are now like 8 years old. So you can't ask them much. Another point I want to mention related to Nvidia, I heard a lot of feedback, for example, on Diablo 4. Because I made a big video on Diablo 4, which was like super like successful, a tutorial on Linux. A lot of users mentioned the fact that there is leaks within the drivers themselves. So you will be in a position where your VRAM become full after a certain amount of time playing. And first I thought it was related to the game itself because it would make sense that the game had a problem. But then I noticed it happened in other games. The amount of VRAM is really important on Linux because the way I understand it, and maybe it's going to be obviously like corrected in the future, but you need a little bit more VRAM to play the same game on Linux than on Windows. And so you could already run out of VRAM pretty fast. So if you are buying any type of graphic card and you already want to focus on Linux, I would say like focus on the one which has like more VRAM, right? Because you're gonna need it. So obviously with my 4090, I have 24 gigabytes of VRAM and I never had this issue. But there is certain like graphic card which won't give you enough VRAM to have a decent experience on Linux. So take that in consideration if you are moving on the Linux train right now. And now the last point, to have a correct, like screenshot of the situation of the Nvidia driver as we speak in fall 2024. The feature. And this is big. This is big. When you look at this video, you're gonna be like, wow, like those graphic cards, they are definitely not ready for Linux. And I would say yes and no. Yes and no, because there is some features which are working very, very well in Linux. So I won't cover anything related to CUDA, obviously, but it works. Out of the box, you install the driver. You have to understand that most of those AI farm, they work on Linux, not on Windows, so the support is like flawless. The other point is related to encoding. If you're a content creator and you encode, when it's related to Nvidia, the experience is awesome. Like this is awesome. I have to say it because I have another like Intel card in my streaming PC, and this card out of the box was not supported at all in Linux. I had to wait like almost 1 year to have a decent support. But I would say like the overall experience while encoding, even if it's a really good card to encode, it's not as great as Nvidia. Nvidia, you install the driver, you are done. With Intel, you have to do a little bit of tinkering, especially when you have to install the driver. It's not as easy, I would say, compared to Nvidia. But it works, don't get me wrong. I would say the user experience with Nvidia is just better there. Other function which works very well is DLSS. So you will be able to use DLSS. There is multiple versions of DLSS. You're gonna have the one related to path tracing, and I think it's called DLSS 3.5. And you're gonna have the basic one, DLSS. Okay, I think it's a 2.0. We'll talk about the other one, like the 3.0, which is a frame gen. And this one is not available yet. You will have Nvidia Reflex. So Nvidia Reflex works. You just need to have the drivers that support it and the version of Proton which support it. Super important. But it works on Linux. Another one which is super interesting is G-Sync. If you have a single screen, it will work. G-Sync work on Linux, no problem. Whether you're on X11 or Nvidia, it will work. The caveat here, talk about it here. So here I'm going to put the features that does not work, okay? This does not work. G-Sync is not supported with multiple monitors. So if you have a dual monitor setup, or only if you are just capturing your screen and not doing a pass-through, no G-Sync. Gone. Super important to take in consideration, because I'm particularly like upset about it because I have 4 monitors. I know the team of Nvidia is actually working on it, but I was expecting them to give it in the 560 series, but it did not happen. I believe it's gonna happen in the future, but we don't know when yet. The other big missing feature here is related to DLSS frame gen. So I think it's called DLSS 3, like correct me in chat, but this is a frame gen one. DLSS frame gen is not supported. So if you have a series 4000, don't count on that. It's not there yet. I also know from open source, that it's going to get implemented, but I don't know how long time it's going to take, obviously. The other point for all the overclocker down there, my opinion, for the latest series of cards, especially the series 40, it's not really worth it, but you won't have any over or under volt. You can't touch it. You can't set it up like in Windows. And don't get me wrong, I'm not talking about setting up the power of the card, because this is available. You can tweak the card as much as you want compared to Windows, but the only thing you can't do is undervolt. This is a big no-go. I think it's a limitation of the driver. I had some discussion with member of the Linux community who told me they were able to undervolt, but I never seen it. I never seen it. So in Windows, what you will do, you will be able to create a special curve for the voltage at different stage of the frequency. And this is what undervolt means. You will define the voltage at different stage. Here on Linux, I couldn't do that. So I could limit the power. You can play with that. You can unlock the power, for example, but it won't have the same effect. So think about it. If, for example, you have a 1390 and you want it to be undervolt to have more performance and consume less, this is not going to happen on Linux yet. Now the other point, HDR. So HDR on paper is available, but the implementation is not great. So it's kind of like a mess situation there. Well, it is what it is. Is it an Nvidia issue? Is it a Linux issue? I can't really tell. But as an end user, don't count on HDR on Linux with Nvidia. There is a way to tweak it. You have to go through GameScope and make it work. But I would say HDR everywhere, it's a pain. Now the control panel. So the control panel, you have one on paper, at least on X11, but it's really, really limited. So most of the other features I'm not talking about right now outside of gaming, they won't be there. And I know some of you guys might be frustrated by that, but they are not there yet. You have to understand that Linux was definitively not the focus, at least for the desktop part, for Nvidia. So at this point, if you watch the whole video, please give a thumbs up and put a comment down below, because I know it's going to be a long one, and you know, you made it until like this specific timing, and I want to tell you you're the best. But outside of that, I would say that the overall situation with Nvidia, it's obviously a mixed scenario, because it's not as good as an experience as you will have on Windows when it comes to gaming. But what I can say is that since I would say like 6 months, 7 months, the way Nvidia has been working on their driver is just, like, I would say, amazing. And I'm not saying that because I'm an Nvidia fanboy or whatever. Like, this is not the case. My approach is really objective in a sense where 8 months ago, I couldn't use Wayland. It was totally impossible for me to use Wayland. Right now, I have a better experience on Wayland than on X11. So that's the first point. Okay, it's just crazy for me to think that in such a small amount of time they were able to get Wayland working, bring explicit sync to the Linux world, because it was some of the caveat of the problematic related to Wayland. And again, I don't want to get too technical there, but explicit sync is there now and working perfectly. The overall experience for installing the driver is getting way better. You know, like 2 years ago, installing the Nvidia driver on Debian was a pain. They kind of like streamlined the installation. They added new feature in which you don't have to go through the TTY. You don't have to do all the extra steps, which were like already awful on certain distro. Now it's a little bit better, or way better, I would say. If you look at the number of like requests and issues they have on their forum, it's pretty big. But from my experience, I had an issue during a driver which was released in beta. I opened a ticket, and the next release of driver, my issue was fixed. So they are working. Do they still have a lot of work? Yes. Like, they have a lot of work. But I can see from my perspective that they are willing to do more and more. When it comes to the gaming experience, it's going to be this type of situation where you give and you take. You know, I said it since the beginning. I didn't even mention once in the video there, but the situation on Linux, whether you have AMD card or Nvidia card or even an Intel card, you might not have as much as FPS average than on Windows, but your 1% low, your frame pacing is gonna be way smoother on Linux, even if you go through translation layer. It's just crazy. When it comes to input lag, there is some specific case scenario where you can have equal or even better, I would say, like a situation, like gaming experience on Linux. It requires sometimes a lot of tweaks, but you can't reach this point. Like, it's possible. So overall, it's gonna be really like, can your Nvidia card with those specific like decrease in terms of FPS while moving from Windows to Linux, it's gonna give it like the expected experience. This is where we are at right now. That's the first one. So me, I'm making my test with the 4090. Obviously, like, you know, the card is delivering, but I do understand, like, if you are using a card which is maybe a little bit older or, you know, a little bit less powerful, and you have, for example, the same screen, or you have expectation towards frame rate, which is fair, you want to make sure you don't go under your, you know, minimum expectation. So this only you can decide, obviously. But what I would say is, like, from my experience, only 2 games and specific feature put me away from Linux while I was playing it. The first one was Alan Wake 2, because I wanted to play the game with RTX to the max, and with the current support of DirectX 12 on Linux, it just didn't make it. Same for Black Myth Wukong. But all the other games, they are more than playable and enjoyable on Linux. Like, I had zero problem with my gaming experience. And it's something like you obviously need to take on consideration. I'm repeating myself, but like with the type of hardware you have. At this point, I'm just really curious to see what the future is going to give us in terms of performance on Linux with the Nvidia card. I have the feeling that in maybe 3 or 4 release of driver, we're going to get to a point where everything is aligned for the Nvidia user to have a really, really good experience, because they reached it in like 2 patches. In 2 patches, they went from like bad experience on Wayland to flawless experience on Wayland. So I'm pretty sure like 3 or 4 patches from now, we're gonna be so lit. And yeah, that's all for today, guys. I think I covered everything. Let me know in the comment below if you think I forget something. I know it was kind of like a long video, but I wanted to really make a state of Nvidia on Linux in fall 2024. I'm planning to do maybe 1 every 6 months, or maybe 1 every 12 months. And I know the beginning of the video was a little bit slow for you to have like a better grasp of everything, but this is it. Guys, I want to thank you all the crème de la crème member for supporting the channel financially. You guys are the best. For all the viewers in general, please give me a thumb up, subscribe. You have no idea how much it helps. We need to bring this channel to the moon. Guys, thanks again for watching, and see you in the next one. Bisous, bisous.